Today, we're going to be talking about transportation data and how it can contribute to mobility equity. And I'll talk a little bit about what the project that we've been working on here, but the project of this sort of initial session is really about getting people in the room to talk about the thorny problems of being able to produce multimodal and accessibility first data and how that really can contribute to mobility equity if we do it right. And the questions we'll continue to ask throughout the day is how do we do it right? Because there's no real good answer just yet. So partners to our Transportation Data Equity Initiative project that is sponsored by ITS for Us, which is a US DOT JPO program, are myself, Anat Caspi, Mark Hollenbeck, who's in the room and director of track, and Kristen Tufte, who's also in the room. And external sustaining partners, and I call them sustaining even though that's not their official name, is because they are really the power behind our project. And it includes Karen Breitmeyer, Alice Marasek, and Adam Danchik for Cambridge Systematics, and Suresh Developoli from Gaussian Solutions. So if you see these people in the hallway, you can ask them any questions. So for this particular session, we'll do a little introduction, which I've already been starting. And what are certain blockers to transportation data equity? What are our project and objectives? And how can the system get us there? And then we'll have two regional data producers that are actually doing it without the TDI. And we want to ask, how have they been doing it? How do they go about it? What skill sets do they need in order to machinate this? And then can we take this away and make it scalable for other regions as well? And then we'll talk about how you can get involved as an agency in our alpha. So what are some data equity gaps and how might they connect to actual open shared data? Essentially what I'm asking is, what is motivating work on open transportation data as a way to mobility equity? And so really it all starts from the lived experience of people with disabilities in urban and rural environments. We've seen this explosion of technology recently, digital technology, digital cartography that has really enabled more travel, access to more locations, and access to more public transit. But not everyone has benefited equally from those technologies. And the image shows a faint background of a complex, very densely built environment. And we know that urban spaces can be really difficult to understand and also to get around. And all these mobile devices and mobility applications on these devices have made a transformative difference for people and how they travel. But as I said, it has not been equal across the board. And so in building our own mobile application, we have talked to many people, and one of them, Kevin, had the lived experience of like saying that actually Google directions sometimes does more harm than good for them because they are sent down streets that they can't cross or up inclines that are impossible for them to climb. And this can be very frustrating. And we know from the experiences of others that it can really halt community engagement. People choose not to engage in the community, not to travel because it's so difficult and so fraught with uncertainty. And sometimes you just don't want to deal with that. And I'll say that from personal experience, this definitely resonates with me. So what really happens when you get any kind of information about accessibility? What I'm showing here is basically what I got from UW when I came to Seattle 9 years ago. I got a UW accessible map, and what it shows here is an image of what the Disabilities Resource Center provided at the time. It's all grayscale. There are variations in intensity that are supposed to indicate what's accessible or how accessible it is, some gradation. It's cluttered, it's complex, it's only moderately accurate because it's kind of dead on arrival in the sense that it's very hard to update and manipulate in real time. And of course, the campus is changing all the time. And so in order to find a route, I have to trace my travel from, don't run away. From a parking lot through each path, I have to evaluate each path, see if it's the right path for me, see if it's connected to the next path, and sometimes that information is available or not. And as often is the case, I need to have plan B and plan C in case the information is not accurately represented there. So, and largely, there's also no clear modality. So I don't know if maybe there's a shuttle that can actually take me from, the parking lot to closer to the location of my destination. So I'd have to integrate a bunch of different sources in order to identify the right path for me. And so clearly, this is the thorny detail of what it takes to travel accessibly as a user. But we know that it's not just the fact that institutions don't want to publish this data. There are a lot of hurdles to actually making this data happen, both in the sense of what is it that we're going to define as the data, how is it going to be consistent, and how do we allow institutional barriers, or how do we remove institutional barriers to allowing agencies and municipalities to actually publish this data and make it easy for them, because it's not easy, as we will hear from our speakers. So some of the barriers that we've identified, first and foremost, are legal and policy. We find that there are lots of legal restrictions or policies that limit or prohibit the sharing of certain types of data. There are also technical barriers, right? Like sharing data needs a certain level of technical infrastructure and expertise. And so that's kind of where we found that the Transportation Data Equity Initiative could kind of contribute. If we make the infrastructure common, shared, and easy to use, then it doesn't have to be something that's in-house to the agency, but rather something that is used outside of the agency. There are also cultural barriers, because some agencies don't necessarily see it their role to share information in that way. And so if you want to show up to our Disability Justice for Transportation and Urban Planners workshop later today given by Olivia, there's some tips and indicators on how you might be able to involve people in that conversation within your organization or agency, so that there is more, cultural willingness to actually look at how to produce this data. There are obviously some institutional barriers, because agencies may have established procedures and policies that don't really prioritize or support this kind of work. And then people are like, oh, another thing to put on the checklist, or it's not always clear how to insert this kind of work into the procedures that are already in place, and oftentimes that becomes a barrier or hurdle. There's also resource constraint, and this is something that I really want to highlight when it comes to specifically sidewalk data, pathways data, which we'll focus on too, which is, what are the paths inside transit spaces, environments, and transit facilities. And also flex data, which has not really had a lot of resources provided for it. So the kind of data that we're talking about today are like environments and services that really do focus on subpopulations or are needed by subpopulations. And they don't necessarily have the commercial interests to invest in, a global imagery collection like a Google Street View collection that would enable you to really wholesale do a single very large commercial effort around it. And for that, we believe that the shared data commons needs to look differently. It can't just, we can't rely on Google to provide these data, but we also can't rely on a single entity to do that collection. So what does the data infrastructure look like when we have all these small contributors with low resources, but we want everybody to be able to interoperate the data, share it, and use each other's data interoperably? Lastly, sometimes there's a lack of incentive. There's no money for it. There's little regulation around it. So what motivates us to actually do it? And data silos and legacy data are already in place. And so it's easy to point to say, oh, you know, we have sidewalk data. It's here in this assets management database. If you want it, you can take it. You know, and oftentimes, you know, we look at these data, there's from 1995, and they have, you know, single line descriptions of what happened on 34th Avenue between Spruce and University. And really all it tells you is that they got some license to cut another curb ramp there in 1988, you know, and that's typically the data. It doesn't tell you where the sidewalks are, how are they connected, what's the connecting point to the crossings, et cetera. And so, and even when those things exist, there's a void in data stewardship. There's not a clear person who wants to say, hey, I own this data, I'll maintain it, I want to keep it. And so any system that we come up with collectively or apart will have to identify those guiding principles on how we want to data steward our work. And I think that that's actually a very local, regional thing. You know, different regions will have to adopt different types of models in that vein. So these are the barriers, and I want to talk about them today so we can remove some of them at least. So our principles or motivating factors behind the work is that behind every useful mobility app, there's a complex data pipeline, and we want to be able to provide reliable and intuitive travel discovery as well as directions. And public agencies and private companies need the tooling for shared data to represent all travel environments and services. Our second guiding principle is that we really want the data to be reliable, objective, detailed, and consistent, where, you know, we want to deprecate subjective assessments done by different entities. And lastly, as a co-author to the mobility data interoperability principles, I do want to borrow from there, where principle 5 is that all individuals and the public should be empowered through high quality, well-distributed mobility data to find, access, and utilize high-quality mobility options that meet their needs as they see fit. And so those 3 tenets are sort of our guiding principles, and I hope that you'll join us today in sharing that vision. So what is the actual work that we're doing here? We are proposing to collaboratively help with accessibility first lens on 3 different data types having to do with pedestrian environments, that's open sidewalks, with pathways, which is in the description of travel environments, and GTFS Flex. We hope to publish and maintain interoperable data tooling infrastructure as well as the data itself. And we're focusing on data collection, data vetting, and data provisioning services, and we'll talk about that later. And then finally be able to deploy and sustain mobility applications that actually use that data. And I think this is a really important part, especially for the data producers in the room. It's so crucial to have the use cases that are actively using your data on an ongoing basis. Otherwise, the data is kind of sitting there. Maybe someone is interested in vetting it, but if there's no actual on-the-ground utility and people are not haranguing you to correct the data on 34th Avenue, it's just not going to happen. And so even though, you know, it creates other kinds of institutional friction, maybe, to creating those kinds of services, it's also really crucial and important in the upkeep of the data. And that's why we're really focusing on these deployments. So who are partners in the TDI? I mentioned some of the others. We also have some backing from ODOT, WashDOT, Maryland DOT, as well as the city of Bellevue and Studio Pacifica. And Karen just came in the room after I showed you earlier. Gaussian Solutions is also here, Microsoft and Google. So I'll skip through the objectives because we already talked about it. And so our big vision is that all people can make informed mobility decisions, avoid data-caused frictions in their trips, that all producers can use public data within their agency and about other agencies, can use public tools that help them in collecting, vetting, and maintaining their data, and can use open data formats, and as in walk the walk on data production with ease. And we really hope to be able to facilitate those friction points if we really understand them. And then finally, transportation data consumers can seamlessly consume data without regional bounds, create innovative travel products. So really, we're hoping to, if the data is consistent and can be used at scale in different regions, then I'm not wasting my time building Access Map just for Seattle. I'm building Access Map for nationwide and beyond that, because I can grab the data easily using just APIs and a bounding box. And finally, we want to be able to use that data for comparative analyses of travel networks and other analyses and comparisons of mobility systems. So without further ado, I do want to say that people are doing this. We're not the first, we're not, but we're trying to create the system to facilitate everybody to do this. And so what I've invited Elliott McFadden and Matthew Weidner to do today for us is to tell us a little bit about what it actually took within a regional effort to do this in-house. And so Elliott McFadden is the Greater Minnesota Shared Mobility Coordinator at the Minnesota Department of Transportation, where he leads efforts to pilot and scale shared mobility services with public transit partners in both rural and small urban communities. He currently serves as the Minnesota DOT lead for their Federal Transit Administration AIM Grant Award to build a regional mobility as a service platform, which he'll tell us about, as well as Western Minnesota COVID-19 contactless payment pilot. He also helped lead Minnesota DOT's Flex Pass parking and transit pass project at the ABC ramps in Minneapolis in partnership with the University of Minnesota. So I'd like to highlight and bring our speaker in remotely.
Thank you for having me here today. Appreciate the opportunity to talk about our project in Minnesota and what we're doing to expand access to transit information, especially in rural and small urban communities. First, I want to start off by talking a little bit about what do we mean by mobility as a service. That is a term that's not well defined, and it can mean different things to different people. So for us, that's a digital platform that allows the sharing of mobility information to visitors and residents, allows trip planning, fare payment, booking, and real-time information where that's available. And our project is integrating transit services as the core service, but also looking at other sorts of shared mobility options that are existing and emerging. And we received a grant from the Federal Transit Administration to do this project under their Accelerating Innovative Mobility, or AIM, program that's focusing on 7 transit systems in southern Minnesota plus our private providers. So this shows you really quickly a map of the service area for this particular part of the project. We have 2 small urban systems that are traditionally what you would think of transit, fixed bus routes with timetables and pickup spots. And then we have 5 rural providers as well that are in the surrounding communities. And in Minnesota, the rural providers are not allowed to do purely fixed route services. So these are all either demand response / dial ride service or deviated route service. In addition, we have a couple other providers that are working with us. So Metro Transit is our provider in the Twin Cities, and they are, well, technically outside of the service area, making sure we're involving the largest transit agency in the state and how we're developing this, so we're not siloed in the development of mobility as a service. And then our intercity bus services, which is Jefferson Lines, and a subsidiary of theirs called Land to Air, is also part of the project. And then we have other providers that have yet to confirm, but are in discussions to be part of this project as well. And then we're also partnering with one of the software providers for a few of our transit agencies, CTS Software, which is the maker of TripMaster, that's going to be doing a booking integration with dial-a-ride service that I'll talk about a little bit later in the presentation. This is a very high-level overview of what we're building. So at the top, you have a consumer interface, a consumer app. And for that to work, you have to have all these different data feeds flow into that. And that's these boxes in the middle. So the purple box is dispatching and routing software in the case of demand response, or that could be operational software for different providers. Data feeds, things like the general transit feed specification or general bike share feed spec, are public feeds that share information about the kinds of services that are being provided, and then the financial transactions. And what we're doing differently on this project that I think makes it more scalable and open to different kinds of uses is breaking out the API management from the consumer app. So API is basically those arrows, those conversations that are happening between these different software platforms that allow the information to be shared and used. And traditionally, what has happened on projects like this is you hire an app company, they go and do all of that stuff, but it is proprietary to that app company. And so you're really kind of stuck with a single app, a single platform to be able to share. And we didn't want to do that. MnDOT is not in the app business, and long term, I don't think we believe in the one app to rule them all idea. So we want, excuse me, we want information to be available wherever people would want to get it, and to create new business models and new partnerships to have creative service delivery. So we split that out on this project, that data sharing and integration component, which allows us, if you see this little box on the right, allows us to be able to also share information with transit agencies and service providers and other trip planning apps. Our vendor on this project is Cambridge Systematics. I believe Brian Jennings is there at the conference from Cambridge, so you can chat with him a little bit more about the work they're doing. They're our lead vendor, and they're doing the API integration. Transit App is the app we're using for the project. Trillium is doing our GTFS development, feed development, and Token Transit is providing e-ticketing services. So if we go back to this schematic, we can see kind of the different roles that the different partners play in this. From the Transit App to the top, you can see TripMaster now in that purple box. And then we're also building a data analysis platform internally at MnDOT to be able to help agencies better understand what's going on with the project. We're heavily focused on data specifications and data standards because we want this information to be interoperable. If you think about those conversations that we're going back and forth, it's like a conversation that you're having with someone across the table from you. If you're speaking different languages, it's hard to communicate. So everybody needs to be speaking the same language for information to be easily shareable. So that starts with the general transit feed specification. In case anyone's not familiar with that, that is the transit industry standard for sharing things like routes, timetables, service areas, hours of operations, fares, that kind of information. And it's what allows platforms like Google and Apple to be able to consume and display information about transit services. We have built GTFS data feeds for all of the participating transit agencies that didn't have that already. And one of the big parts of this was building GTFS Flex data feeds. So when I talked about those rural transit agencies, they don't do traditional fixed route service, which is what GTFS was originally designed to do. So it's not terribly helpful for them, but there's an emerging part of the spec, GTFS Flex, that allows flexible services, things like demand response, paratransit, and deviated route services, to be searchable, to be able to display information about those routes and services. And what's exciting on this project is Transit App is the first major trip planning app to consume that information natively within their trip search engine. which is a big step towards getting this officially adopted as part of the GTFS spec, and encouraging platforms like Apple, Google, Move It, other big platforms to show this information as well. But we didn't stop there. Cambridge has built a trip planning engine as well that supports GTFS Flex based on Open Trip Planner, which is an open source trip planning engine. So if we are sharing information with another app and they don't want to develop their planner to consume that information, they can plug into that module and be able to show GTFS Flex. And then the other area that we're working on is that booking part. So once we get past discovery and we want to get into information that we're actually sharing an individual trip request, how do we standardize that information? And there's an emerging spec called the Demand Response Transactional Data Spec that allows you to share that in an interoperable way, much like GTFS does for trip searches. And so that'll be part of our integration of demand response booking. I wanted to show you, we launched this in March, early March, and wanted to show you how non-fixed routes are showing up in the transit app. So this is a deviated route service in Albert Lea, Minnesota. So you can see the blue line is the actual route, and then the bubble around that is the route deviation. So that's the area that the agency will deviate off if you call ahead to either pick you up or drop you off. And then we also have demand response and /Dollaride and Paratransit services that are in the platform as well being displayed. In this case, you're seeing service areas, and it can get quite complex. In this instance, this is True Transit in Minnesota, which surrounds the community of Mankato. They do not provide service directly within Mankato because Mankato has their own flexible service as well as Paratransit. And so you can see that donut in the middle shows you that that isn't a service area. However, they do provide service from their area into Mankato or from Mankato to dropping off into their service area. And so Flex allows you to do that, allows you to see those kind of trips and those options. And all of them allow a book by phone option right now. So when folks hit that button, that's going to connect their device. And if they have a cellular signal, actually directly call the Dollaride service and be able to book. So in the future, we will be adding a button there that actually allows that trip information that's being searched to be shared over into the routing and dispatching and scheduling software using the demand response transactional data spec. So this is an example slide of what those data specs look like. It's a fairly comprehensive spec that deals with everything from the trip request down to scheduling to reporting and kind of more operational information. On our project, we're focused just on that client to trip request part of this spec. And we're also finding there are some data areas that aren't covered by this. So we're looking at how we develop that further as well. This is a little more detailed schematic of how we're building this. I think the big thing I want to point out is on the left, you see the different data sources from the different providers. And this orange box is really the key part of this project. All this information flows through this box, which Cambridge has been building for us, designated our mobility hub. And that is where that Open Trip Planner module sits. That is our feed aggregator. So one of the nice things is all of the agencies that are sharing information from us are in that feed aggregator. So there's a single spot where third-party apps can plug into, as well as our data warehouse that is storing historical information so we can do further analysis. Quick on our timeline, we started work with Cambridge and their subcontractors back in May of last year. We launched in March of this year with trip planning and mobile ticketing. We are going to be launching a web-based trip planner currently planned for sometime in late May. So folks who don't have a mobile device but do have access to a web page can be able to do trip planning. And then that further integration, being able to do actual booking with demand response is currently scheduled for the end of summer. And then our pilot with FTA ends next spring in 2024. We did develop an equity and accessibility plan as part of this project using the equity frame lens work that MnDOT has developed to look at projects. And so what we did was look at certain communities that we needed to be paying attention to as we roll out this technology and determine what sorts of changes need to be made to better address those communities. So that would include communications issues like rural residents that don't have reliable access to mobile data, and persons that don't have a smartphone, or they do but they don't have a data plan, persons with physical disabilities, people who don't speak English as their primary language, and the unbanked and underbanked. All of this is part of our larger technology plan at MnDOT to look at this technology and determine whether we want to deploy this statewide and eventually scale this, and sort of what roles that we are going to play, Minnesota IT or Minute, which is our technology division, and the individual agencies. We also see opportunities in the future for standardization around billing and data integration with non-emergency medical and social services. And then also looking at how this fits into personal automotive technologies like parking and tolling, which exists today, and the distance-based fee, which is being developed across the country as a replacement for the gas tax as we electrify fleets. So that this could potentially be part of a larger mobility wallet where we're really offering people information about all their transportation choices and being able to provide financial incentives and disincentives for different modes of transportation. With that, I will wrap up and hand it back to our host, I guess, for our next presenter.
Thank you. Thank you so much for that. We appreciate you joining us today. Next up is Matthew Weidner. He leads the strategic planning and systems analysis for King County Metro's demand responsive transportation practice. In this role, Matthew leads the agency's DRT research and spearheads the translational technology initiative. Sorry. I need to turn theoretical research into operational reality for DRT. He also advises the agency's DRT strategic technology direction and guides its investment in innovative and emerging mobility programs. And I know this to be true because we've partnered with Matthew before. I'm so glad you're here.
Thank you, everybody, and thank you for the invite today. For not everybody here, I'm happy to see so many familiar faces, and I'm happy to see everybody who's interested in this topic, because this is near and dear to my heart and near and dear to, I think, a lot of people here today. So me, Matthew Weidner, I have about 20 years in the demand response sector. I'm an analyst, kind of a researcher. I do lots of stuff, so let's just skip that part. King County Metro, for those online or not local, is the transit agency for the greater Seattle metropolitan area. We have a ginormous budget. We are the 10th largest transit agency in the United States, 4th largest bus fleet, and we have the 2nd largest electric trolley fleet, which is unique for this area. Woot woot. So we have a variety of modes, including van pool, we have some passenger ferries, we have a paratransit, we have lots of stuff. So we are a large and we are a complex agency. And everything we do at Metro is based on our long game. So we build our systems with safety, equity, and sustainability in mind, which allows us to demonstrate the value to our taxpayers and our local citizens, which allows us to invest more in our local transit service, and measure our progress, and we begin the cycle all over again in hopes of building healthy communities, thriving economy, and a sustainable environment. So everything we do is based on this. Though coming out of COVID-19, we know in the, if anyone is a Daft Punk fan, that the game has changed. Transit, what people expect from transit and what people want from their future transit system is no longer what it was. And some of the ways, I'll describe a couple. Our ridership has declined and has not rebounded. I, for one, used to be a daily transit rider, and that's no longer the case. And that is the case for so many people in the region. So how do we adapt to that? One of the things we have to realize is that the onboard experience is sometimes lacking and unhelpful. And we put people with mobility devices into an information vacuum. We no longer, when compared to an ambulatory person and the information that's provided relative to their abilities, what we give to those in mobility devices and with other disabilities is lacking. Secondly, your expectations have changed. We can blame a small company named Uber for that. And Steve Jobs, who gave us cell phones. May he rest in peace. Customers want things digital first. They turn to their phones for information and to accomplish things in their daily lives. This includes for transit agencies. And they want the services they use to be digitally transparent. All the information that they should need to accomplish their journey should be available on their devices. And they should also be digitally actionable. They want to accomplish things when they ride transit. And we need to be able to interface that actionability with our systems. Oh, and lastly, we need to include equity in everything we do for every trip. When transit agencies were formed in the 1970s, we inherited what is a very unequitable system. Bus stops that customers can't use, signage that doesn't work, and we've been trying to build accessibility onto those systems ever since. So if we're exploring new systems, we need to be able to build in equity from the very beginning, not as an afterthought. So how do we respond to these different changes? This is something that I get to think about in my job, which is fantastic. And so today I'm going to talk about some new service models that we are thinking about and exploring, as well as how we're thinking to address the roadblocks that are in front of us when we're thinking about these new service models. So I want to give you an example of a little place south of here named Kent. Who's ever been to Kent? Oh, lots of people. I got two hands in the back. So for those of you online and those who have never been to Kent, it's a suburb south of here. It's a mix of light use, semi-heavy industrial, how would you describe it, valley, combined with some residential areas on the hill. So if you look at the map to your east, there's mostly residential, and to the west is more in the industrial job center. And in this city, Access Paratransit service, which is our largest demand response service, covers the whole area. If we look at other services that Metro also offers in this area, Pingo, which was recently renamed Metro Flex, operates in the service area to the north, offering demand response service as well. And then we have a DART route, which offers demand response in this service area. To the south, the ride Pingo goes to the north, Metro Flex. And so for all these areas, we have different availability. We have Access Transportation, which covers the entire area, which operates 24 hours a day, 7 days a week, and has a service fleet of 340 vehicles available at any moment. Metro Flex has lesser weekday service, 2 vehicles, and DART has 3 vehicles with even less service. So now, you as a consumer, you live in Kent, and you want to get from point A to point B, which service would be the most useful? Paratransit service, yes! The largest demand response service we have, which is designed to transport people with disabilities from point A to point B, is also our most effective demand response service in this area. Yet we deploy 3 different products to serve 3 different audiences in the Kent area. This is kind of insane. So why, from the get-go, didn't we combine them? Well, the answer is that our transit system is a little bit broken. We are operating in an environment where we have basically 2 different types of software that we are deploying at this point that are, in some ways, have different objectives and serve different customers. Paratransit and deviated fixed route software was built for transit agencies, for compliance purposes. Newer mobility as a service software is built for customers first, to offer the experience, the digital first experience that we are all expecting. They also have different, various different things, which you can read here. But one of the things that is very pertinent in the paratransit space is the heavy amount of customization, which makes things very difficult to integrate with other modes. So the standard solution to solving this problem has been a single silo approach. And as we've heard from the others, the silo approach has its problems. This is especially problematic when we're dealing with different programs. In terms of a complicated system like King County Metro with many different needs, many different customizations, very unique service territory, we found that the single silo approach just isn't workable. Each software vendor is there for a specific purpose, and they were selected for a specific need to fulfill that purpose. So trying to smash everything into what is the monster mother of all mobility as a service software packages is just too difficult. So if we're stuck in a world where we have these different programs, uncoordinated, in different silos, how do we crack that nut? How do we allow, say, a MetroFlex service to achieve a higher level of service where it has access to 340 vehicles, 24 hours a day, 7 days a week? How do we give those customers that digital first service, yet are able to leverage the resources that are already on the street in these other programs? One of the things we're thinking about and actively looking at is something that we're coining, or tentatively calling, federated demand response commingling, a method by which we can coordinate resources across demand response programs. Each underlying software package does what it does best, but through an orchestrator, it is able to tap into the resources of those other demand response programs in the area. How we're kind of thinking about this is that each software package, accepts customer requests, operates just like it does today, and each mode operates similar to what it does today. Yet the orchestrator steps in to optimize efficiency and service delivery across all demand response programs, with the ability to calculate prospective cost delivery in each demand response system in real time. So what does that look like in a functional sense? Well, I'll first say that Anat showed that it could be done with a talented group of students, that we can calculate the prospective cost of each demand response trip in a highly dynamic demand response environment where the cost to deliver a trip fluctuates minute to minute, hour to hour. So in this case, we have a paratransit trip on, I can't see the preview. So we have a paratransit trip on our paratransit system that is very expensive. It is what we call an ugly trip, one that will be very expensive and take resources away from areas of demand density. But on the deviated fixed route system, we can see that there's a vehicle that is already serving in the area, has a trip that aligns, and the orchestrator can see that it would cost less to serve that trip on the deviated fixed route system. So the orchestrator can try to facilitate a trip transfer, and if for some reason the deviated system can't take that, let's say there's something that is not visible to software, that person or those people managing that system can deny that. But if it does work, if there is a good solution that costs less, gives better service to the customer, and doesn't disrupt operations in the other system, we could transfer that trip, thereby moving a paratransit trip to a vehicle that is primarily assigned to serving the dedicated fixed route, or the deviated fixed route system. This results in lower costs overall for the transit agency, fewer total resources that we need to put on the street, and also a better customer service experience. We can also use this type of framework to identify, to resolve service defects. So someone's running late, a vehicle breaks down. How do we use those other resources in order to resolve that? And again, Anat's group, somewhere in 2015, showed how this can be done. How we can look across a paratransit system and independently calculate new solutions without our proprietary, without using the proprietary solution finding. So if we apply this, again, across multiple demand response systems, we can see that there's a service defect on our mobility as a service software, and we can reassign that trip to be served by our paratransit system seamlessly, thereby, again, reducing overall required resources and offering a better customer experience and improving everybody's lives. So the question is, what is holding us back from implementing something like this? I was pleased to see Elliott's presentation, because a lot of what he showed you has a lot, those problems have a lot of relevance to what I just showed you. Again, data standards. Data standards for demand response systems just aren't there yet. So to build independent third-party systems that are plug and play, where we can interact with multiple different vendors and all speak the same language, those data standards just don't exist. We have some great organizations, Mobility Data, which is working on these types of data standards actively in order to facilitate a more independent, interoperable software stack for our transit systems. And then King County Mobility Coalition with HopeLink, Stacy, woot woot, working on working on other systems to facilitate these types of information sharing between separate software stacks. So that's challenge number one. Challenge number two is the current economics of enterprise software in the transit industry. We have a number of entrenched actors who view transit as a zero-sum game. They win, the other guy loses. We have to, I don't know how to change this dynamic. And this is probably one of the hardest parts of this, is how do we get these software vendors to realize that working together actually is in their own best interest. And the third issue is us. It's transit agencies. We have a talent pool that is mostly built upon individuals who plan bus networks and bus routes, and they have gone to master's programs at such esteemed programs as University of Washington. But if you look at the curriculum of those master's programs, technology is not a part of it. We are not training the next generation of transit planners with the skills that they need. They need to be able to think in APIs and not KPIs. They need to think about interoperable data frameworks and not intermodal transit. They need to think about what is the network of technologies they are deploying to serve their customers instead of the bus routes. Secondly, we need the tools in order to manage a digital-first system. So that includes all kinds of different tools across the agency that are not built with a digital-first customer experience in mind. And we need, like I mentioned earlier, these software vendors that we work with to adapt open software standards for everyone. And thirdly, the tactics. We need leadership that understands the technology of today and tomorrow and how to leverage it in order to accomplish these ends for our transit systems and identify the value proposition that it presents to transit agencies as a whole. So it is a long road that we have to go before we can get to where we want to be. And that's where we need you. If you look around the table at the people who are sitting next to you, those are the people who are going to be building the next generation of transit systems. We need you to dedicate your expertise to this. We need you to embrace these ideals and the vision for what can be accomplished for an equitable, interoperable, and better community for us all, because our neighbors depend on it and the planet depends on it. So I am very hopeful with all the people that I see here who are embracing this, and I hope you will join us, and I hope you will continue the good fight. Thank you.
Wow, that was inspiring. Thank you, Matthew. We appreciate you coming here. Actually, this is a perfect segue because we're hoping to be able to facilitate just a tiny piece of that technology piece that would ease gliding into technology without necessarily having all those tech skills in-house to enable those agencies to create and produce data at scale. And so I'd like to introduce Kristen Tufte. And I realize I left my notes over there. Kristen joined the University of Washington after many years at PSU. She was lead for a data aggregator at PSU, and for many years has 20 years and over experience working with transportation data at scale. She's a big data expert and brings her expertise to us, to the Transportation Data Equity Initiative, as our technical lead for the ITS for Us program. Please welcome Kristen.
Okay. All right. Thanks, Anat. And good morning. It's wonderful to see all of you here in person, and as well, greetings to those folks on Zoom. My name is Kristen, and I work with Anat and team on the Transportation Data Equity Initiative. And so I'm going to spend a little time talking about the system that we're building in the Transportation Data Equity Initiative. I want to first take a moment to thank the ITS JPO of the U.S. Department of Transportation for their support of this project. We are grateful for their support. The Transportation Data Equity Initiative is one of 4 ITS for U.S. projects. It's focused on mobility and transportation information for folks with disabilities. If you're interested in the program, there's a link here. Okay, I like to start with this slide. And this slide is I'm going to go back a little bit to the motivation for the project, which Anat talked about a bit. And I have on the right-hand side here a map from Google Maps. It's from an engineering building, which is, I think, right there towards the near the fountain on the University of Washington campus. So if you're not familiar with the UW campus, you can imagine this is directions near your home or your place of work. And the question I have for you today is this path useful? Or what do you need to make this path useful? If you have a wheelchair, maybe you're pushing a stroller, maybe you broke your ankle, or what have you. What additional information, is this useful? And what types of additional information might you want? I'll give you a second to think about it. So some things that come to my mind are there stairs? Is it steep? What's the width of the path? Are there any obstacles in the path? And I want to really acknowledge that there are folks in this room and on Zoom with lived experience in this area, and so I want to acknowledge that you understand this infinitely better than I do. So the point is that, okay, this is fantastic on some levels, but it may not be fantastic if you have a mobility disability, if you're in any one of these situations. And so there's 2 things that I want to say on this slide. And one is that, yeah, okay, maybe this technology is great, but to my eyes, this technology has really not had an equal application, and in fact has increased sort of the disparity in the quality of information available to those who are, let's say, abled versus those who have different mobility abilities. So I see the technology as not bridging that gap, but increasing that gap. The second thing I want to say with this slide is that to give folks more and better mobility information, better directions, the gap is actually in the data. So the application and the applications to give improved directions exist. It's the data where we really have a gap. So part of our project is to collect that data. And as there may be some planners in the audience, the next two slides are if we go and collect this data to improve those mobility directions, what else can we do with the data? Well, one thing we can do is improve walk sheds. So in transportation planning, it's very common to say how many people can walk to transit. And one way that's historically been done is to draw a circle around the transit station, which is shown in the little yellow dots in the middle here. Okay, but that does not include slope, it doesn't include sidewalks, and if we gather this information, we can do we can improve these walk sheds and hopefully make them more equitable. One of our end goals, this is a screenshot from Access Map, which is an app that is in development at University of Washington. To agree with Elliott, we don't believe in one app to the be-all, end-all. It's our hope that many apps will be developed based on our data, but this is one that we're working on. And the concept here is that I can go to Access Map and I can give it customized travel directions. So I can say, I don't want stairs. I'm kind of feeling tired today. I'd like only just a slow incline today. And so the idea is to give users the ability to customize their travel preferences. Okay, so how are we going to go about this? So we're building a data system. This is a concept diagram of the system. And I have a picture up here today, but this system functions. So thanks to Suresh and his team, we have a functioning version of this system. Data generators, or those who produce data, you're on the left-hand side here. I guess you're about 30% of the audience, I think. Data consumers, you're on the right-hand side. And what the system is capable of now is it takes data in, it stores the data, and then you can retrieve the data out. It's a bare bones framework. I liken it to maybe like the skeleton or the framework of a house. But it is there, and it does function. So we're at the point where we have a framework developed. And one of our asks today, which I'll get to in a couple slides, is we're really looking for folks to work with us to help figure out how to build out this house. So right now, we have an API. So you interact with the system through an application programming interface, which is a way for two computers to talk to each other. And like I said, it's pretty simple. You can put data in, and you can get data out. We've also created a user management front end. So if you have an agency or organization and you want to store data in our system, then you can register your users. We have a designated agency point of contact. You can say who can and can't upload your data for your organization. So the very short story of these two slides is we've got a system that functions, takes data in, it does a minimal amount of data vetting at the moment, and you can get that data out. But this, like I said, this is just a start. For the data producers, is what we're requesting you to provide us in the API. Can you provide that data? For the data consumers, how do you want to download the data? Do you want to ask for data by a geographic area? Do you want to ask for data by organization? And further, what tools do we need to provide to enable your agency to get data into our system? So, our ask today is we're looking for some alpha partners. So alpha is even prior to beta, right? So we're just looking for a couple, so it's a few agencies to work with us to help us, like I said, figure out how to build out this system. So expected commitment is a couple 1 to 2 hour meetings or interviews. We would hope that you would have some data that you would be able to provide us. Sidewalk data, street crossings, needs to be in electronic digital format. Beyond that, I'm not going to put any restrictions on it. And hopefully an ability to test the API. So, but this is not a one-way street. if you decide to join us as an alpha partner, then we will absolutely support you through the process. So this is intended to be a partnership. The gain for you is you get to get your data early into our data system and perhaps publish that data, and you will help us further design the system. So this is what we provide to you as an alpha partner. I've got a URL here if you would like to join us, or if you're interested, you can talk to myself or Anat throughout the day, today and tomorrow. So that's what I have. Here is some contact information, and thank you all.
What we were hoping to do, we have a couple of minutes left in this session, is to take questions from the audience, whether remotely or in person, and you can address them to any of the speakers. We will try to do this in a hybrid fashion. A little skeptical, but any questions? And let me check out online. Oh, the Zoom has been closed. Are there questions? Yeah. Sally Swanson.
You know, I'm in San Francisco, and we lived through COVID. I have an office downtown that was dead. I mean, nobody was there. And now people are coming back, but they're not using BART. And you know we have a serious homeless problem, and I guess they all hang out with BART. But what I've noticed that's really frightening. You know, I go in the opposite direction. I live south. Most people are going across the Bay Bridge. Is that it's backed up for miles and miles. And I just don't understand why BART, you know, just hasn't taken more of an incentive. You know, something to cross for 20 minutes will take 2 hours and 20 minutes. And what needs to be done? I mean, you gave a real broad brush, which I found very exciting. But if you could just share some of the incentives, you know, I'd love to share it with Bart.
You know, one thing that I think transit agencies need to lean into is, I don't know how to describe it, but the right-of-way advantage. You know, we have these bus systems, and in some sense you can call them legacy bus systems, where they have not been built up from the ground up to serve customers' needs. I mean, they inherited, all these systems have been inherited, and we're just making edge changes over time to these local bus systems that have been basically the bedrock of our transit agencies. My thinking, or I think the way that we're thinking about this, is that someday we're going to refer to those local bus services as legacy bus service, because they really aren't serving the customer's needs. But if we lean into the right-of-way advantage, if we lean into you know, a municipality's ability to basically exclude other users from a pathway, so from a bridge lane, from, you know, link light rail, we have all this. We can really accomplish amazing things if we are willing to lean into that right-of-way advantage and dedicate more right-of-way to transit and to high-frequency, clean, safe transit that delivers people along those corridors much more quickly. And we really haven't made that turn. A lot of transit agencies are really stuck with thinking about transit as bus networks. And that's not the case. We really need to think about all the different modes that we can deliver. How do we make those modes attractive? And how do we lean into that right-of-way advantage in order to deliver the speed and the efficiency that we need? Does that answer your question?
Yeah, thank you.
Okay.
Our perspective, we recently completed some research about bringing folks back to transit and shared mobility post pandemic, because what we saw was many people going back to personal cars, but transit and shared mobility being slower. And so I think what we found in this report was both things like making sure you've got good, clean, you're addressing sort of those public safety parts of the conversation, but also services, just as we've been talking about, making those services better, more in tune with how people are moving. What we've seen, the services in the Twin Cities that have bounced back on fixed route have been the ones that are increasing services during the day, because travel patterns have changed. We're not solely looking at commutes. And so, so are you guys hearing me?
Yes. Sorry,
yeah, okay.
It was my fault.
Realizing I'm talking and talking and talking, and maybe nobody's hearing a word I'm saying. So anyway, so that, and then like microtransit services as well, and many of our demand response services have picked right back up because they're more attuned to how people are moving and actually serving them. So, so I do think, really focusing on those services is a huge part of it. I would say on the other side, talking to your city, if you make parking easy, or free, if you're doing things that make it easy and cheap to use a car, people are going to choose that. So they also need to be making policy decisions that are making it, frankly, less convenient and more expensive to use a car, while you're improving the transit services as an option.
Thank you. So we have some questions from chat, but there were other questions in the room.
Hi, this is another question from Matthew. I wonder if you could speak to how your bus planning is impacted by other regional transportation providers such as Sound Transit.
Unfortunately, I can't, because I'm a demand response guy. Is there another Metro employee here? Oh, come on up. Hey, Melissa.
Hey everyone, I'm Melissa Gunn. I'm a senior business analyst in service planning. I am not a service planner, so I'm going to keep this pretty broad in general. Generally, we work in collaboration with our regional partners. We work really closely in collaboration with Sound Transit, FDOT, and every city in King County. And we're doing our best to make sure that our service works well in collaboration with theirs. But that being said, we can't control their decisions and we can't control their timelines. So yeah, that's the general answer. Does that answer your question?
Yes.
Okay, cool.
Thanks, Melissa.
All right, there was a question on the chat regarding how we, and I'm assuming it was asked generally, are planning to conflate some of the data that is existing with the new data that is being produced. I will say for the Transportation Data Equity Initiative, that is a thorny topic for sure. It really firstly depends on which data specification we're talking about. Some of these data never existed to begin with, so we're kind of in the clear there to some extent. Some of the data is highly transitory in the sense that it changes on a temporal basis and quite frequently, so we can sort of start anew because we're just capturing what's currently there in demand response right now with Catholic Community Services, and that's our starting point, and we'll continue to conflate that going forward. The sidewalks question is a big question. In some cases, contributors have made a lot of effort in contributing data, say on OpenStreetMap. There are also contributions from municipalities and organizations that have already made considerable efforts to collect sidewalk data. We have found that about 80% of people who have collected that data have done so in rather inconsistent ways. And so it took us a whole year to take Seattle DOTs, even though it's good data, to actually transform it to a form that allowed us to do any kind of graph routing over it because it was not connected. So in some sense, starting over sometimes might actually have the greatest benefit, particularly if we're interested in having that transportation layer represented as opposed to oh, there's a sidewalk here and it starts here and goes there, but no connectivity information. So that's been our experience, but I'm happy for others to share how they intend to do conflation. We do intend to at least be able to do various types of error checking that allows us to check against or match against other existing data. But that too would require a lot of manual intervention. So the question is there a cost benefit analysis to actually seeing what was there before or just collecting the data de novo? And that question is still an open question because we have not done a lot of conflation other than through our machine learning predictions, comparing those to what people did on the ground in OSM. I'll let others speak.
Oh, I don't have anything.
Elliott, any responses to conflation questions?
No, I think you handled it well.
Okay. All right. I think I'm super sorry if I missed any other questions. Oh, David Miller asks, GPS systems intended for visually impaired, blind, and even deafblind end users do not provide any intersection interface in terms of type, available APS, etc. So route creation features of those apps send people into intangible options. Sidewalk quality, edge detection features for wayfinding are all absent. Yes, so I think this is where it comes down to data specifications and understanding the local and regional concerns of people with disabilities so that we not only offer the basic line layer of where are the sidewalks and how are they connected, but these specific details that allow people to enter, especially the contested areas of the pedestrian network, which are crossings. How is this crossing both controlled in terms of traffic lights, yield signs, stop signs, as well as the understanding of what will I find here when I approach this intersection in terms of the button to push for the APS, what will the APS provide, et cetera, et cetera. So I think when it comes to the different regional flavors, what we're trying to do with the data specification that we're putting forward, Open Sidewalks, is to allow for that flexibility because different regions are built differently. And so these specific data attributes will change based on those regions. And so we need to allow the spec to be rigid about how to describe the transportation layer, but not rigid about those local attributes that people care about. I hope that responds.